3, 2, 1, go. 1.71. Go.
This is our roller coaster, and we start at all the way gravitational potential energy, and once it's going down, it's gaining all of its kinetic and losing its gravitational potential energy. Then it's going up, and it's gaining more gravitational potential energy, and it's losing some kinetic, and then it's gaining back its kinetic energy and losing its potential, and then it has no kinetic and potential energy.
1. One.
Actually, no.
2, 1. So friction and air resistance when it's going down the hill, friction is happening when it's rubbing against the hill because it's slowing down continuously, and then when it's at the curve, it's and also for the hill, it's also using air resistance also slowing it down, and the friction and the air resistance are slowing it down for the curve because it's as it goes around, the friction keeps rubbing against the material, and the air resistance also slowing it down at the same time, which is continuously making it slower. But then once it goes down here, the friction starts to get starts to make a less of an impact on it, and it will just keep going down, and the air resistance will make a less of an impact, and then it'll go up the hill, and then it'll start going to the catcher, which will the friction and air resistance will help it stop, and the wall it runs into will make it stop completely.
So we start with the law of conservation of energy, which in the funnel, it goes down. It's losing its potential, but the kinetic is getting destroyed, and then we go all the way in the curve, and then it's gaining kinetic, and it's losing its potential more, and then once it's going up, it's making more potential, and it's losing kinetic, and then it goes down, losing potential and gaining kinetic, and then the catcher pressure makes it lose kinetic and potential.
So we put the funnel right here to begin the project, because if it's right here, it will go down through the hole to the hill, which is where the kinetic energy gains, the potential energy decreases, and the kinetic energy increases. And we put it here because it gains more kinetic energy here. And then we go down the curve, which keeps the kinetic energy flowing while at the same time still moving. And the reason why we put it here is because if we put it here, then the energy will still be going but not completely stopping. And then it will go down the hill and up the hill down into the catcher. And we put the hill right here so it could go all the way down here and then go through there, so it could so it will still have, so the kinetic energy will go down here to the potential energy, and it will go all the way into the catcher, which will catch the ball. One, go.